Now, Karl Pearson's correlation coefficient in the previous video, we've already mentioned that it is based on the concept of the covariance. In fact, this is just a slight modification of the covariance formula, where the correlation coefficient, which is denoted by R, is equal to the covariance between x and y, variables x and y, divided by the product of their standard deviations. So let us call this formula 1, because we have another formula which is a slight modification of this formula, formula 1, and what we get is R equal to summations xy divided by the square root of the product of the sum of squares of x and the sum of squares of y. Now here x is it represents the deviations from the mean of x values, and y is the deviation from the mean values of y. Okay, so this is another formula of computing Karl Pearson's correlation coefficient. So to apply this formula, these are the steps we need to follow. First, we compute the arithmetic mean of x and y values. That is, find x bar and y bar. We find x bar and y bar. Then we find the deviations of x values from mean and deviation of y values from the mean. In other words, we have to find small x and small y, where small x is nothing but x minus x bar, which is the deviations from the mean value, from the mean of x values, and small y is nothing but y minus y bar, which is the deviation from the mean of y values. So that is the second step. Then you square the deviations, you add them up, and you get summation ex square, summation ey square, and you multiply the deviations to get summation xy, and you simply substitute it in formula, which is formula number 2. So if you look here, we just need to find the value of this exy, the value of summation, the value of the sum of x squares, which is nothing but the deviations of x values from the mean, and the sum of the deviations of the sum of the squares of the deviations of the y values from the mean. So let us use formula 2 in solving the same sum that we have solved previously. Okay, we use the same sum, same example. So from the following data, we calculate Karl Pearson's correlation coefficient. So we follow the steps. For the first step, okay, let us first put down the x values. Let us put down the x values. So these are x values: 2, 3, 4, 5, 6, 7, and 8. Now the first step here is to first compute the arithmetic mean of x. Let us first find the arithmetic mean of x. Arithmetic mean of x is equal to the sum of the x values divided by the number of pairs of observations. So how many pairs of observations we have here? This is one pair, second pair, third pair, fourth, fifth, sixth, seventh. So n is equal to 7. And summation x, we add all of these values together. Okay, using a calculator, we get 35. So the mean x value is 35 divided by 7, which is equal to 5. Now the next step is to, let us first find for the x series. The next step is to find the deviations of x values from the mean. So we have to find the value of small y. The value of small y. So your small value here is, your small x is deviation of the x values from the mean. and your mean value here is equal to 5. So x minus 5. So all the x values subtracted from the mean value. So 2 minus 5 minus 3, 3 minus 5 minus 2, 4 minus 5 minus 1, 5 minus 5 0, 6 minus 5 1, 7 minus 5 2, 8 minus 5 3. So it is important to use signs. So these are positive. Okay, so that is for the x series. Now we'll move to the y series. 4, 7, 8, 9, 10, 14, 18. So we already know what n, and to find the mean of the y values or the y series, we need to divide the sum of the y values by the number. So we add all of this up, we get 70. So 70 divided by n is equal to 7. So a small y, which represents the deviation of the values of the y values from the mean. So your small y is y minus 7. So these are your y values. Oh, sorry, this should be 10. My mistake. This is 10. Sorry about that. Careless mistake. So y minus 10. So these are your y values. You subtract them from 10. So y minus 4 minus 10 is minus 6. 7 minus 10 is minus 3. 8 minus 10 is minus 2. 9 minus 10 is minus 1. 10 minus 10 is 0. 14 minus 10 is positive 4. 18 minus 10 is positive 8. Now the next step, we found the deviation. The next step is to square the deviations, and you find the sum of the squares of the deviations. So small x square, okay, small x square is nothing but the square of these values over here. So you have to take the squares of these values, okay, and what we get is minus 3 into minus 3, 9, minus 2 into minus 2, 4, minus 1 into minus 1, 1, so 0, 1, 1, 2 2s are 4, 3 3s are 9, so we find the sum, we get 28. Next we find the square of the y deviations, the square of the y deviation, which means we square these values over here. Sorry, that's a mistake. It's not those values because this is capital Y, so I made a mistake. I thought that was this small y. In fact, the small y's are over here. Small y's are over here. So minus 6 into minus 6 is 36. Minus 3 into minus 3, 9. Minus 2 into minus 2, 4. Minus 1 to minus 1, 1. So we square the values, you find the sum, we get 130. And the next step is to, sorry about that, the next step is to multiply the deviations and to get the sum, which means you multiply the x values and the y values. So this x values, the small x and the small y value, so we multiply the deviation. So minus 3 into minus 6 will give us positive 18. Minus 2 into minus 3, positive 6. Minus 2 into minus 1, positive 2. 0 into minus 1, 0. 1 into 0, 0. 2 into 4, positive 2 into positive 4, positive 8. Positive 3 into positive 8, positive 24. And we find the sum, we get 58. So the last step is simply to substitute these values or put these values in the formula. So you put the values in the formula. So putting these values in the formula, we get, so this was a formula. which is 58. 28 into 130. If you multiply that, we get 3640. Find the square of that, we get 58, square root of that, sorry, 60.33, and if we divide that, we get positive 0.96. So there is a high degree positive correlation between X and Y. So what we notice is that we are getting the same value. We got the same value if we apply formula 1. So it is up to you which one is more easy for you. You can either use formula 1, formula 2, because it doesn't change the concept of a correlation. The correlation is still equal to the covariance between X and Y divided by the product of the standard deviations of X and Y. Formula 2 is just a modification of formula 1. So you'll get the same answer.